Good morning. In this video, we are going to study about the surface treatments, especially surface welding and laser hardening. This is from surface engineering subject, and also I am David, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Surface welding. In surfacing welding, a heat, wear and corrosion resistant metal coating is deposited on a workpiece, surface or edge. Surface welding can improve product performance, maximize material utilization and increase part useful life. In the process of surfacing welding, materials with particular qualities are applied to the surface of using welding techniques. Surface welding serves a different purpose than conventional welding techniques. Surface welding alters the workpiece surface rather than joining the pieces together to create a cladding layer with certain attributes such as resistance to heat, corrosion or wear, or to restore a workpiece inadequate size due to wear or manufacturing mistakes. Benefits of surface welding: high bonding strength and superior impact resistance are produced via metal to metal bonding between the surface layer and the base metal. The surfacing layer's thickness can be changed from 2 to 30 mm, making it better suited to harsh wear. Surface welding reduces cost and improves the economy. It is possible to save a lot of precious metals when the workpiece substrate is constructed of common materials, because it involves expanding or shrinkage pieces through welding or applying an alloy layer with unique qualities to the surface of the parts. Surfacing technology is very practical. This kind of work can be done by welding technicians. Types of surface welding. First one, hard facing. Hard facing is a type of surface welding where a stronger material is deposited to the workpiece. The purpose is to change up the properties of base metal, which then enhances its strength, durability and resistance. The next type is build-up. Build-up is the addition of weld metal to a surface, joint or a prior weld of the base metal. The main purpose of building up is to restore worn out layers or sides of a workpiece. Then weld cladding. Cladding is not far from what hard facing is. However, the goal of cladding is to apply elements or components that are corrosion resistant. The last one, buttering. Lastly, buttering is a surfacing type where a metal without a similar properties are deposited. You can understand it better as a deposition of alloys with high nickel content onto alloyed steel. Thermal spray coating. Thermal spray coating is a process that sprays coating materials using the pressure of a high heat gas. The material then bonds to the surface, forming a coat that grants properties such as corrosion protection, thermal resistance, environmental protection, lubricity, wear resistance, and electrical conductivity. Coating materials usually come in powder or wire form through a feeder and may include metals, alloys, ceramics, carbides, plastics, or composites. The spray gun is also known as spray torch, is the main tool used to perform the operation. So this is one kind of thermal spraying, that is plasma spraying. Plasma spraying makes use of plasma gun to spray the coating material onto the substrate. A powder feedstock is introduced into a plasma jet, where it is subjected to a high temperature of the flame. The heat turns the powder into high velocity droplets traveling at up to 800 meters per second that adhere to the substrate, where they cool off and solidify to form a protective coating. Then we can study about laser hardening. Laser hardening, also referred to as laser case hardening, is a heat treating process used to improve the strength and durability of component surfaces. It employs the use of high-powered diode layers that apply energy to heat localized areas of the component surface. As the lasers move across the surface, it instantaneously heats and the surface get desired case above the aesthetic temperature. As the laser passed over this volume of metal, it self-quenches rapidly through the conduction, resulting in the formation of martensitic structure, and consequently the hardening of the material takes place. The process of laser hardening: first, the positioning the workpiece beneath the diode laser. The laser hardening process is suitable for nearly any steel or cast iron that contains carbon. The workpiece can range from simple to highly complex. The next step: activating the laser. Once the workpiece is in the correct position, a pre-programmed robot program activates the laser, which heats the localized area's surface to just below its melting point. The last procedure or step is moving the laser across the component surface. The area under the laser beam instantaneously reaches the desired temperature. The laser beam is programmed to move across the surface of the workpiece along a pre-programmed path. The laser energy per unit area, which is determined by the laser power and surface speed, determines the hardened case depth. Once the laser moves over an area, the area rapidly conductively quenches. The rapid quench prevents the carbon atoms from the returning to the original lattice formation and producing harder crystalline structure known as martensite. It is structure that hardened case. Thank you.